Okay, so for this first one here, okay, first mark is obviously for our givens. We know the mass is 6.2 kilograms, okay, and we know the maximum displacement, which we also call amplitude, is 0.8 meters. And we know that there's a springs constant, K, of 5.7 newtons per meter. Okay, and we're looking for the displacement, which in this unit is x, okay, when it's moving at 0.65 meters per second. Okay, so 1 mark if they have that. All right, what kind of problem are we dealing with here? It's a conservation of energy question. We know that the energy it has at its maximum amplitude, which is all potential, is equal to the total mechanical energy at this second position where they want to know the displacement. All right, so EI equals EF, okay, and we know that that can mean the initial potential plus the initial kinetic equals the final potential plus the final kinetic. Okay, it's just that we know in this first situation that there isn't any initial kinetic energy. So if they got something along those lines, give them their second mark. Okay, so we have elastic potential energy. That's all we have at the initial point. Okay, so that's going to be 1/2 Ka squared. And then on this side, we're going to have 1/2 Kxf squared plus 1/2 mvf squared. Now, I'm looking for that. So what should I do with the kinetic energy right now before I plug in any numbers? I should subtract it over to the other side. All right, so I'm going to have 1/2 Ka squared minus 1/2 mvf squared equals 1/2 Kxf squared. All right, now I'm going to manipulate to find the thing I'm supposed to find, which is xf. All right, so first off, half is in every term, so I'm getting rid of it, just like I did with mass in the first unit. It's in every term, so I can get rid of it. Okay, if you didn't, it's fine. It'll still work out. Then I'm going to divide both sides by k, and then I'm going to square root. All right, so if they have something along those lines, and I'll draw it all out here, just got to make some room. So if they have something along the lines of this, xf equals, okay, the square root of Ka squared minus mvf squared over k square rooted. Okay, that will be their third mark. Okay, numbers plugged in correctly, so that would be 5.7 times 0.8 squared minus 6.2 times 0.65 squared divided by 5.7. Okay, that can be their fourth mark, and then that will get us our final displacement, or how far from equilibrium it is when it's moving at the requested speed. Okay, so we'll have 5.7 times 0.8 squared minus 6.2 times 0.65 squared, okay, divided by 5.7, okay, square rooted. All right, so its displacement at that point is 0.42 meters, but we only have one significant digit. So it's actually 0.4 meters. Fifth and final mark for that one. Okay, questions on the first one? Okay. All right, in our second one, we have a pendulum swinging back and forth, and again, they tell us the amplitude, which is actually measured as a height for a pendulum, is 0.5 meters. Okay, so I'm going to say H initial is 0.50 meters, and recognizing that that's its maximum amplitude, I'm also going to write this. They didn't outright tell me that number, but I know it's true because at the highest point in the pendulum's oscillation is where it turns around and starts coming back, so its initial velocity or speed is 0. Okay, now it's looking for the speed of the pendulum when it's at a height of 0.18 meters. So that's going to be my final height. And I'm going to have that I'm looking for VF. All right, that's all they give me. They didn't give me the mass. Is that a problem? It is not a problem, because this works just like a roller coaster. So this is like a review question from Unit 2. Okay? A pendulum has gravitational potential energy, not elastic potential energy. So 1 mark for givens, 1 mark for recognizing it's a law of conservation of energy question. Okay, we don't have any initial kinetic energy. We are looking for the final speed, so I'm going to subtract EP final over here. So EP initial minus EP final should equal EK final. Okay, and then that's going to be M times G times H initial minus M times G times H final equals 1/2 MV final squared. So if they have something along these lines as a manipulation, you can give them a mark there. Okay, the masses are going to cancel, thankfully, because we weren't told what it was. And I just need to divide both sides by 1/2 and square root to get VF. So their 4th mark is for that final manipulation, or if they just plugged in the numbers, okay, that's fine too. So 9.81 times 0.5 minus 9.81 times 0.18 divided by 1/2, all square rooted. So okay, that's their 4th mark. All right, so we got 9.81 times 0.5 minus 9.81 times 0.18 divided by 0.5, square rooted. All right, so the speed at that point will be 2.5 meters per second. 5th and final mark there. Okay, questions on that one? All right, give them a mark out of 10 at the top, let them see it, and then put them on the desk in front of Callie, please.